Hello everyone, this time we will discuss reliability test. Please subscribe on my channel.
Reliability. So you need to identify if the test is reliable. Reliability is another characteristics of a good test. So usually after a validation of the test, its reliability is tested. So reliability is a factor of validity. So that is if a test cannot be valid without being reliable. However, validity is not a factor of reliability because a test can be reliable even without it being valid. So we have this reliability we are going to review. So in any research, this is a degree to which it gives an accurate score across a range of measurement. So it can thus be viewed as being repeatability or consistency. So this refers to the consistency and accuracy of the test. So a reliability test therefore yields essential the same scores when administered twice to the same students. So we have types of reliability. The first is iterator. We have the split half method, test-retest method, parallel form, and the internal consistency. The split half method. A split half, from the word split half, so test or single knowledge area is split into two parts, and then both parts given to a group of students at the same time. So we have here an example, an item of 6 items. You split the item 1, 3, and 5, and then second group is item 2, 4, and 6. The split half testing is a measure of internal consistency. How well the test components contribute to the constructs that's being measured. It is commonly used for multiple choices, but you can also use it for any type of test, even tests with essay questions. How to split it half? You can split into first half and second half, or you can group into odd and even numbers. If the two halves of the test provide similar result, this would suggest that the test has internal reliability. We have the steps. Administer the test to a large group. Ideally, we are using the standard, the 30 apps for quantitative research. Randomly divide the test questions into two parts. For example, separate the even and the odd questions. Score each half of the test for each student and find the correlation for the two halves. Another is the test-retest reliability. This refers to the extent to which a test or a measure administered at one time is correlated with the same time or measure administered the same people at another time. So we have here an example, time 1, this is same as time 2, and then get the reliability of the test, and then the second test, retest. If the correlation between separate administrations of tests is 0.7 or higher in the Cronbach's alpha of internal consistency, then it has a good test-retest. So we have there from 0.8 to 0.7, acceptable. We have 0.8 to 0.9, good. So questionable if less than 0.7, like this 0.6 to 0.69, that's questionable. And you may, if you come up the questionable, you may revise. But if you have poor and unacceptable, you are going to delete the questions and make another new questions. So you can revise from 0.5 to 1. That is only from 0.7 have higher Cronbach's alpha. We have some conditions. It must be the same experiment tools or intervention, the same observer, the same measuring tool or instrument used in the same condition, the same location, repetition over a short period of time, and same objectives. So, matter ang time. Like, you have the test now, and then you have another retest in tomorrow, the following day. We have disadvantages or the limitation. It takes a long time for results to be obtained. If the duration is brief, then participants may recall information from the first test which could bias the result. And if the duration is too long, it is feasible that the participants could have changed in some important way, which could also bias the result. So we have an example. Example situation here. Ms. Riston administered her statistics test to 10 first-year college students. After a week, the same test was given to the same group of students. So we have their score in the first and the second test are given in the next slide. Compute the reliability of the test. So we are going to use the correlation. Anyway, I will going to post another video how you are going to solve correlation using Microsoft Excel. And this is for the manual computation of the Pearson correlation R. We are going to follow the formula. R is equal to n times the quantity summation of xy minus summation of x times summation of y over the square root of n times the quantity n times summation of x squared minus the summation of x squared. And multiply to the summation n times summation of y squared minus the summation of y squared. So based on the table here, the scores in the first test, we have x 40, second test 41, then xy you're going to multiply 40 times 41, 1640. You squared 40, so 1600. And you square 41, 681. After that, you carefully get the sum of x, get the sum of y, get the sum of the product of x times y, get the sum of all x squared, and get the sum of all y squared. So summation of x here is 304, summation of y is 303, summation of xy 9843, summation of x squared 9924, summation of y squared 9841. So substitute in the formula here, n is 10, there are 10 scores here, times the summation of xy 9843 minus summation of x 304 times 303 divided by the square root of 10 times the summation of the 304 squared minus the summation of x squared 9924 multiplied to 10 times 303 squared minus 9841. Okay, so the result here, it means we have 0.94 rounded off to 2 decimal places. So it means very high relationship. So according to the range here, the interpretation, if you have 0.94, that is excellent. Okay, you're going to revise only if that is less than 0.7. So thus the result is statistics test is reliable.
Thank you for watching. Please don't forget to subscribe on my channel. You can recommend a topic to review in the future. God bless everyone.